The following is a quick introduction to using classes in Python. Classes are the way that object-oriented programming is implemented. So rather than having simple variables, we'd like to be able to group things together that more effectively expresses the organization and grouping of those objects. So we can think in terms of objects like a person, and objects have attributes, like a person has a name, age, weight, hair color, race, etc. And objects can also perform actions using functions. So a person can use the attributes to calculate other properties or to sing or to run, move, etc. So we have two main things, the attributes or the data members or the variables that the class holds, and corresponding functions that the class has. So we'll illustrate this with an example, a cube class. So we define, just like we define a function, we define a class, and we use the keyword class and then give it a name, in this case cube, end it with a colon, and then we're indenting, so everything indented is part of the class definition. So here we have three different functions defined. The first function is called setSide, and it sets the side length of the cube, which is the primary attribute. There's also this self argument. Self is always the first argument of these functions, and we'll discuss it some more in a minute, but self can be thought of as the actual instantiation of a cube object. And so when we call the function, it passes the object itself, and then we can assign to it. In this case, self.length equals the side length that we pass in. We're creating number of sides is 6. About is the string squarish. And then we have, so that's this first function. Then once we've set the length of the object, we can then use it. So we have a new function, volume, and self is passed to the volume, and then we can return the volume, self.l cubed, or an area, self.l squared times the number of sides, in this case 6. So this is the class definition. Let's go ahead and see the, use it. So once we've created the class, or the class definition, we can create class objects. So we can do C1 is cube1, C1 equals a cube, C2 is also a cube, and these are two completely different cube objects, C1 and C2. We can then set C1.setSide, and we pass it the side length is 2, C2.setSide, and we pass it the side length 3. And then we can use the side length, so print the sides equals C1.L. Remember when we called set side length, right here, set side length 2 and 3, we're calling this function set side, we pass in 2 and 3, and then we store those as L. And then when we call volume and area, we use that L to compute the corresponding volume and area. And that's what we're doing here. So C1.L is available, C1.area, C1.volume, and it prints 2, 24, and 8. And then the corresponding values for C2, which are bigger because it's got a longer side length. If we just type C1.about, we can see that's a string, and the string was squarish. Cubes are squarish. So we can see here when we did self.about, squarish. So this is the two parts. We create the cube, we define the cube, and then we go ahead and create cube objects, and they look kind of like function calls. And then we can, once we have the objects, we can call the objects member functions, C1.setSide, C1.setSide, C1.area, volume, etc. It's possible to change the values. We could do C1.L equals 22, and then that resets the value, and then C1.volume, volume, will go from 8 to something much bigger, 10648 in this case. So you have quite a bit of access. You can even create new attributes on the fly. So we could do c1.color equals blue, and then we can go print, we can just output it c1.color, and it's now blue, and that can be used anywhere we like. Okay, let's talk a little bit more about self. In the class definition, self is a function argument, and it refers to the object itself. When we define the class object, when we define the cube class, every function inside the class will have its initial parameter will be self. So we'll do self, self, self. And then all other parameters come after. When we call the function, that is, once we've created cube objects, when we call all these functions, we pretty much just ignore self. It's completely ignored. Now, you can think of that as when you do c1.area, the c1 dot, effectively, where Python is passing c1 as the first argument for you. So area expects two arguments, self and, well, it expects one argument, self. Set side expects two arguments, so the first argument is self, and the c1 dot is effectively passing, you can think of it as passing c1 as the first argument. So it becomes self. The self object refers to the object itself. So if you call set side, let's go look at that function. If we call set side with c1, if we go c1.setSide, then self refers to c1. So self.l can be thought of as c1.l. Self.nsides can be thought of as c1.nsides. If we called c2.setSide, then self refers to c2. So it'd be c2's l, etc. Again, when we define the class member function setSide, we had self and side. When we use that function, we leave off the self argument because it's implied by the c1 dot. Okay, so here's an illustration. Normally we call member functions with the dot notation like c1.area, and self is automatically passed in. That is, c1 is passed in. It's possible also to call the function using cube.area and then explicitly pass c1 in, explicitly pass the object. So we can see here AA is c1.area and AB is cube.area c1, and when we print those we get the same thing out. So here we're explicitly passing self, we're explicitly passing c1 in, and here c1 is passed by default. Okay, we can also initialize. When we initialize the class, there's a special function called __init__, and that is implicitly called. If you create that function, then it's called automatically when you create an object. So this can let us initialize data members without a separate call. So let's redo the cube class with an init function. So instead of having a set side function, we're just going to go def __init __, and then as usual self, and then the side length, and then we set data member self.l is side length right here, and then the other functions are just like they were. So when we call the function, before we just did c1 equals cube with empty parentheses, and then separately we did c1.setSide. Here we're doing c1 equals cube 2, and so when we create this cube, it automatically calls the init function, and it passes in 2 into the side length here. So it's a convenient way to initialize the class. And we've been using this with other libraries such as NumPy, when we go import NumPy as np and then a equals np.array, for example. When we do something like import NumPy as np and then do a equals np.array 1, 2, 3, we're creating an array object, and it's got this as the initializer. So here we're creating a cube object, and we're initializing its side to be 2. Okay, and when we run this, we can see, let's go ahead and run the class first. This new class, and it takes these arguments and gives the same kind of output. Okay, so as an exercise, we can try creating a cylinder class. So you can pause here and go ahead and try to create a cylinder class. And we'll go ahead and do that. Class cylinder. And then let's do an initialization function, init, takes self, and then we think about the key cylinder objects would be like the height and the radius. And then we can go self dot h equals the height, and self dot r equals the radius. And then we can have other functions like def, volume, self, and return the volume of a cylinder will be pi 3.14159 times self dot r squared times the height, self dot h, and maybe the area def area self return 2 times pi 3.14159 times self dot r plus the area of the ends, if we want to include that, 2 times pi r squared self dot r squared times 3.14159. Okay, and then that creates the cylinder object. Then we can, that defines the cylinder class. Then we can create some objects like sil1 equals, call it sil1 equals cylinder, and we pass in a height of 1 and a radius of 1, and maybe sil2 can have 2 and 3, and then we can go sil1 dot area, and we get a value, and we can go sil2 dot area, etc., and call these various functions. So there's a quick introduction to the very basics of using classes in Python.